Good morning, students. So we'll move on to the module number 4, that is data and analytics for IoT. So here, the name only indicates we need to deal with the data. Okay. So after gathering the information from the smart devices, sensors and actuators and all, so we need to go for a procedure called as analytics. Why we need to go for this? Because we are deploying hundreds of thousands of sensors and smart objects in the real-time environment. So they'll be gathering the bulk of information, like each and every minute, each and every second, they will be sensing the information, and that the data will be flooding towards the application layer. So if you let all the information or all the bits of information to reach the application layer, then it will be we may face the choke in case of network. Okay, like your network may get restart because of bulk of information. Okay, so we will be having some like limitations, right? Like how many MB of information can be handled at a time, or any such type of, okay, the capacity of the network. Okay, if it is exceeded, okay, then the network will get restart. Okay, so these are the few problems, okay, what we may face in the IoT network. So what we need to do, we need to go for the analytics part. So each and every information what you are gathering, okay, we cannot surely say that each and every bit of information is useful for the real-time environment. Okay, some the temperature sensor, always it will be sensing the temperature, right, in every tick of second. Okay, so it will be sensing the information, but we may be targeting for the low temperature, and we may be targeting for the high temperature. So in between that, if temperature is there, then what is the job of the application layer? Like we don't, no need to take any action over there, right? So this is what the analytics part do. Like whenever the information of the temperature we get, okay, if it is less than the minimum temperature and if it is more than the maximum temperature, then only it should be handled by the application layer, remember. Okay, so that part we are calling it as analytics. Okay, so we'll move on to the technicalities of this module. Okay, so we need to discuss different kinds of data. Okay, like we are having structured and unstructured kind of data. Okay, then different types of tools we need to deal. Okay, total 4 different topics we need to discuss under this module. It's a very easy module, okay, compared to the rest of the module, like module 2, which where we are having lots of discussion regarding IEEE formats and all. Okay, such type discussion we don't have here. It's a general kind of a module, exactly. Okay, so at first, IoT data is just a curiosity. Yes, obvious. Okay, and it's even useful if handled correctly. However, given time, as more and more devices are added to IoT network, the data generated by this system becomes overwhelming. Yes, obvious. When we are introduced with IoT technology, okay, we were very curious, like, yes, we can sense the information in the absence of the human. We can sense the information and we can take certain necessary action. Is it right? Okay, we are having the actuator who is responsible for taking the action in case of necessary condition. Is it? So we were curious about that, but when we are going in deep to this technology, okay, we overcome with lots of sensors, lots of protocols and all. Okay, then obviously the information what you are gathering will be more. Okay, not only does this data being to consume precious network bandwidth, okay, but server resources are increasingly taxed in their attempt to process, sort and analyze the data. Yes, obvious. So if we are gathering lots of information, obvious, like we are dependent on network, right? Then the bandwidth what we are available with, and the resources what we are available with, so maximum part will be consumed for this portion itself, like collecting the information, sorting them, right? So this chapter provides an overview of the field of data analytics from an IoT perspective. It includes the following section. There are 4 sections exactly. We'll see that. An introduction to data analytics for IoT. So this section introduces the subject of analytics for IoT and discusses the difference between structured and unstructured data. It also discusses how analytics relates to IoT data. Okay, so here in today's session we'll be discussing regarding an introduction to data analytics for IoT. So where we'll be discussing what exactly structured data stand for and what exactly unstructured stand for. Okay, so we'll be discussing regarding that. Then later, next discussion will be towards big data analytics tools and technology. So big data is one of the most commonly used term in the world of IoT. So this section examines some of the most common technologies used in big data. today, okay, including Hadoop, NoSQL, and MapReduce. So regarding this, what are the different tools are available? If okay, fine, like we are having a bulk of information, we are having a big data available with, so we cannot neglect each and every information. Is it right? Okay, we need to have some tool who is responsible for handling them. So these are the tools we are using. Then later, next step will be edge streaming analytics. So this is very important. IoT requires that data be processed and analyzed as close to the endpoint as possible, okay, in real time. So this section explores how streaming analytics can be used for such processing and analysis. So streaming means what? Like when you are collecting the information in the smart device level, okay, so that will be communicated directly to the gateway. From gateway, backhaul network we are having, then application layer will be encountered, right? So the gateway and the backhaul, there we are calling it as a edge analytics level, okay. The information where you are collecting, there itself it will be processed. Remember this information where we are collecting, there itself it will be processed. Then if necessary information will be there, if it is available, feel that you are grasping total 10 MB of information, but out of that only 500 KB will be very most essential information. Feel that, okay. Then instead of transferring 10 MB of information back to the application layer, what we do, we are targeting that 500 KB exactly. Then the network resources available will be as usual. We are not going to overload the network, okay. Then the lots of problem, okay, what we may face because of huge amount of data will be avoided exactly. Then later, network analytics, the final section of this chapter investigate the concepts of network flow analytics using flexible net flow in IoT system. Net flow can help you better understand the function of the overall system and highlight and heighten security in an IoT network exactly. We'll see that what is this net flow exactly. Net flow is a network protocol developed by Cisco for collecting IP traffic information and monitoring network traffic exactly. Okay, so that is what we are calling it as net flow exactly. So in upcoming topics we'll be discussing regarding so each and everything. But now in today's session we'll be discussing about an introduction to data analytics for IoT. So we'll see that what exactly this data analytics stand for, okay, why we need this data analytics, what are the different situation we are facing, okay, if we want to go for this, okay. In the world of IoT, the creation of massive amount of data from sensor is common and one of the biggest challenges. Yes, obvious, because we are deploying lots of sensors, so obvious. If each and every sensor is sending 1 MB of information per second, then if you are having 1,000 sensors deployed, then just imagine, okay, we'll be getting 1 GB of information per second exactly. Not only from a transport perspective, but also for a data management standpoint exactly. So this big data is not a challenge for transferring the information towards the application layer, but also like we need to manage them, right? Okay, so for that also it is a more challenging part exactly. Modern jet engines are fitted with thousands of sensors that generate a whooping 10 GB of data per second. Just imagine thousands of sensors are fitted for one engine. You can observe a commercial jet engine. We are having a picture right in the right bottom corner. Okay, for example, modern jet engine similar to one of the shown in the figure 7.1 may be equipped with around 5,000 sensors. Just imagine. Okay, just imagine 5,000 sensors. Okay, so here we may expect 50 GB of information per second, because we need to be dependent on, you may ask like why we need to go for 5,000 sensor for this jet engine exactly. See, if anything, any problem is there in our car or bike, okay, so we may park it next to the road or else in the parking lot or somewhere, okay, but during our drive itself, okay, we can take for deviation and we can park it aside the road exactly. But what we can do with aircraft, is it right? Okay, so the plane and all, or fighter jets and all, okay, like regularly real-time information we need to get. So if there is a problem, it should be clearly intimated for the pilot so that he can take some necessary action. Otherwise there is a huge amount of life threat available, right? Okay, so therefore a twin engine commercial airjet with these engines operation on average 8 hours a day will generate over 500 TB of data daily, and this is just the data from the engine. Okay, aircraft today have thousands of other sensors connected to the airframe and other system. Okay, in fact, a single wing of modern jumbo jet is equipped with 10,000 sensors. You just imagine, we are taking an example of aircraft exactly. Okay, so if like if a one wing is consisting of 10,000 sensors, then per day, like per day 8 hours if they work, okay, then just imagine 5,500 TB of information we are getting from these particular engines exactly. So what we need to do, we need to go for analytics parts. Okay, analyzing this amount of data in the most efficient manner possibly falls under the umbrella of data analytics. So data analytics must be able to offer actionable insight and knowledge from data. Okay, no matter the amount or style. Okay, in a timely manner. Okay, or the full benefits of IoT cannot be realized. Okay, before diving deeper into data analytics, okay, it is important to define a few key concepts related to data. For one thing, no, not all data is the same. Okay, it can be categorized and thus analyzed in different ways. Okay, depending on how data is categorized, various data analytics tools and processing methods can be applied. So here we need to discuss regarding two different data types over here. The two important categorization for an IoT perspective of whether the data is structured or unstructured, and whether it is in motion or at rest. So we need to deal with this very careful, because the information whatever we are generating, we cannot say like if you are with IoT network, so everything will be structured. No, it is not. Okay, few sensors are there. Okay, fine, they'll be following the schema. Okay, they'll be following the reference module. So they'll be generating the data in a proper structure. Okay, but few are available. Okay, so they are deployed in IoT network also, but they are generating the data according to unstructured fashion exactly. Okay, so we'll see that what are the different structured and unstructured data available. And moreover, we are having another category like whether the data is at rest and data is at motion. Okay, we'll discuss that. What is the data at rest and motion? Structured versus unstructured. So you can observe, okay, we have a picture where it is showing like structured data. You can observe there is a proper rows and column. Okay, so the information will be stored in proper alignment exactly. Okay, organized format, we are calling it as spreadsheets or data sheets. Okay, but unstructured data, you can observe, we don't have a proper arrangement over here. Okay, does not comfort to a model. Okay, so text, information and images, video and speech, we are considering it as unstructured data. So we'll go through this. Structured data and unstructured data are important classification, as they typically requires different tool set for a data analytics perspective. Structured data means that the data follow a model or schema that defines how the data is represented or organized, meaning it fits well with a traditional relation database management system, RDBMS we call it. As structured data can be found in most computing system and includes everything from banking transaction and invoices to computer log files and router configurations. Okay, so these are the, we call it as few things as structured data exactly. Okay, IoT sensor data often uses structured values such as the temperature, pressure, humidity and so on. Okay, so which are all sent in a known format. So structured data is easily formatted, stored, queried and processed. For these reasons, it has been the core type of data used for making business decisions exactly. Okay, because of the highly organized format of structured data, a wide area of data analytics tool is readily available for processing this type of data exactly. Okay, so from this discussion we got to know like structured data will be well suited for analysis part. Okay, because we may go for particular tool. Okay, because the data which is generated is in proper format which is expected by the tool, so we are feeding the tool with the proper structured data. Okay, then finally we will be getting the result exactly. But when it comes for unstructured, we'll see that unstructured data lacks of logical scheme for understanding and decoding the data through traditional programming models. Okay, then example of this data type includes text, speech, image, and video. As a general rule, any data that does not fit nearly into a predefined data model is classified as unstructured data. Obvious, like randomly, if you are generating the information without any structure or without any policies, then we are calling it as unstructured. Exactly. Smart object in IoT networks generate both structured and unstructured data. Structured data is more easily managed and processed due to its well-defined organization. Okay, but unstructured data can be harder to deal with and typically requires very different analytics tools for processing the data. Exactly. Okay, so these were the discussion regarding the structured and unstructured data. Okay, last this like introduction to IoT analytics part. Okay, so also covers regarding data in motion versus data at rest. Okay, data in motion means what? Like if you are collecting the information, that will be stored there itself. Okay, using some secondary storage device or using some primary storage device, doesn't matter exactly. But if you are transferring the information to some X location, okay, for application layer, for edge computing or anywhere, then we are calling it as data in motion. Okay, so we'll go through the discussion. I hope you got some idea. Data in motion means through the network, if you are transferring, we are considering it a data in motion. Data as rest means the sensor, if it is sensing the information, if it keep it with itself, okay, instead of sending it to somebody else, then we are calling it a data at rest. As in most networks, data in IoT network is either in transit, okay, data in motion, or being held or stored, data at rest. Example of data in motion include traditional client server exchanges such as web browsing and file transfer and email. Okay, data saved to a hard drive, storage array or USB drive is data at rest, we are calling it as. Okay, so this is the example. Okay, the data from smart object is considered data in motion as it passes through the network and router, okay, to its final destination. So this is often processed at the edge using for computing. Okay, so when data is processed at the edge, it may be filtered and deleted or forwarded on for further processing. Okay, and possible storage at a fog node or in the data center. Okay, data does not come to rest at the edge. Okay, obvious, whenever we get the information at the edge level, either it should be processed, either it should be deleted, or either it should be handled and it should be forwarded for the further. Exactly, we are not going to store them in a edge level. Exactly. When data arrives at the data center, okay, it is possible to process in a real time, just like at the edge, okay, while it is still in motion. Especially tool for structured data is relational database are available from a data analytics perspective. The best known of these tools is Hadoop. So Hadoop not only helps with data processing but also data storage. So these were the few concepts, okay, we were discussing about the structured data and unstructured data and data at motion, okay, and rest. Okay, so these were the few information which will help us to go for dealing with big data and analytics part. Okay, I hope you don't have doubt regarding this topic, because this is a very general kind of topic. Like we are deploying lots of sensors, then lots of information will be available. So what we need to do, we need to handle them properly. Okay, so then we are having some category like structured and unstructured, and we are having one more category like data in motion and data at rest. Okay, so we need to concentrate regarding this aspect. Then later we need to go for certain decision, we need to go for certain tools, okay, who will be helpful for us for handling them. Okay, okay students, so we'll meet with the next topic in next session. Thank you.